Good day, everyone. I am Teacher Hannah, your teacher for this lesson in Grade 8 Mathematics. And our lesson is about rational algebraic expressions. But before we start, let us have first a recall about polynomials. A given expression is a polynomial if there is no negative exponent. Let us have, for example, x raised to negative 4 plus 4x minus 12. Since we have a negative exponent which is negative 4, then this expression is not a polynomial. Another, there should be no radical sign or fractional exponent in the variables. For example, x raised to 1 half minus 2x minus 4. Since we have a fractional exponent which is 1 half, then this expression is also not a polynomial. Let's have another example. 3x minus the square root of y. Since we have a radical sign in the variable y, then this expression is also not a polynomial. And there must be no variable in the denominator. For example, x squared minus 2x over y plus 1. Since we have a variable in the denominator which is y, then this expression is also not a polynomial. Let us now define rational algebraic expressions. A rational algebraic expression is a ratio of two polynomials provided that the denominator is not equal to 0. In symbols, we have P over Q, where P and Q are polynomials and Q is not equal to 0. Let us have some examples. Determine whether the following is a rational algebraic expression or not. Number 1, 1 minus m over m cubed. The numerator 1 minus m is a polynomial, and the denominator m cubed is also a polynomial. Thus, this expression is a rational algebraic expression. Number 2, 4 plus b over 6b minus 2 plus 3b is not a rational algebraic expression because the denominator has a negative exponent which is negative 2. Number 3, b minus 1 over 3b plus 6b squared. The numerator b minus 1 is a polynomial, and also the denominator 3b plus 6b squared is a polynomial. Therefore, this is a rational algebraic expression. And number 4, c raised to 4 over m minus m. The numerator c raised to 4 is a polynomial, but if we simplify the denominator m minus m, it will be equal to 0. And the denominator cannot be equal to 0 because any number divided by 0 is meaningless or undefined. Therefore, this is not a rational algebraic expression. Next, let's have determining the excluded values. In rational algebraic expressions, you need to pay attention to what values of the variables that will make the denominator equal to 0. And these values are called excluded values. Let's have the steps in determining the excluded values. Step number 1, let the expression in the denominator be equal to 0. Therefore, in determining the excluded values, we are only going to pay attention with the denominator. And step number 2, solve the equation to determine the value or values of the variable. Let's have example number 1. Identify the value of x that will make 6 over x minus 3 undefined. Step 1. Let the expression in the denominator be equal to 0. So let's have the denominator x minus 3 be equal to 0. Then, solve the equation to determine the value of the variable. So for this equation, let's copy x equals 0, and we are going to transpose minus 3 to the right side of the equal sign, and the minus sign will be changed to plus sign. And 0 plus 3 is equal to 3. Therefore, the value of x is 3. What happens if you substitute 3 to the expression? Let's have again the expression 6 over x minus 3. Let's copy 6 over, we're going to substitute 3 to x, so we have 3 minus 3. Then, again, copy 6 over 3 minus 3 is 0. Since any number divided to 0 is undefined, therefore, 3 is the excluded value for 6 over x minus 3. Example number 2. Identify the value of n that will make 18n plus 1 over n squared plus n minus 2 undefined. So step 1, let the expression in the denominator be equal to 0. So let's have the denominator n squared plus n minus 2 be equal to 0. Then solve the equation to determine the value of the variable. So for this equation, we are going to use factoring perfect square trinomials, and the factored form will be the quantity of n plus 2 times the quantity of n minus 1 equals 0. And let's have first n plus 2 be equal to 0. Copy n is equal to 0. And transpose plus 2 to the right side of the equal sign. So plus sign will be changed to minus sign. And 0 minus 2 is equal to negative 2. Thus, n is equal to negative 2. Next, let's have n minus 1 be equal to 0. Copy n is equal to 0 and transpose minus 1 to the right side of the equal sign. Change minus sign to plus sign. And 0 plus 1 is equal to 1. Thus, n is equal to 1. So what happens if we substitute these values to the expression? So let's have first, if n is equal to negative 2, again, let's have the expression 18n plus 1 over n squared plus n minus 2. We're going to replace n by negative 2. We now have 18 times negative 2 plus 1 over negative 2 squared plus negative 2 minus 2. Next, 18 times negative 2 is negative 36, and copy plus 1. Negative 2 squared is 4, plus negative 2 will be minus 2, and then copy minus 2. So the answer will be negative 36 plus 1 is negative 35. 4 minus 2 is 0. Next, let's have if n is equal to 1. So again, let's have the expression 18n plus 1 over n squared plus n minus 2. And we're going to replace n by 1. So 18 times 1 plus 1 over 1 squared plus 1 minus 2. 18 times 1 is 18, copy plus 1. 1 squared is 1 plus 1 minus 2. And the answer will be 18 plus 1 is 19. And 1 plus 1 minus 2 is 0. Since both the denominators are equal to 0 and any number divided to 0 is undefined, therefore, negative 2 and 1 are the excluded values for 18n plus 1 over n squared plus n minus 2. Next, let's have evaluating rational algebraic expressions. So, step 1, replace the variable in the given value. And step 2, we're going to simplify the numerator and the denominator. Let us have example number 1. Evaluate the expression y squared minus 1 over y cubed minus 3 when y is equal to 2. So step 1, replace the variable with the given value. So we are going to replace y by 2. We now have 2 squared minus 1 over 2 cubed minus 3. And then, simplify the numerator and denominator. 2 squared is 4, copy minus 1, over 2 cubed is 8, and copy minus 3. And the answer will be 4 minus 1 is 3, and 8 minus 3 is 5. Therefore, when y is equal to 2, y squared minus 1 over y cubed minus 3 is equal to 3 over 5. Let's have example number 2. Evaluate the expression 5x squared plus 6x minus 11 over 1 when x is equal to 2. So, replace the variable with the given value. We're going to replace x by 2. We now have 5 times 2 squared plus 6 times 2 minus 11 over 1. And then simplify the numerator and denominator. So we now have 5 times 2 squared is 4 plus 6 times 2 minus 11 over 1. Then 5 times 4 is 20 plus 6 times 2 is 12 minus 11 over 1. And the answer will be 21 over 1, or 21 divided by 1 is 21. Therefore, when x is equal to 2, the expression 5x squared plus 6x minus 11 over 1 is equal to 21. Let us now move on to simplifying rational algebraic expressions. The key concept of simplifying rational algebraic expressions is the concept of reducing a fraction to its simplest form. Let us have an example in fraction form. Simplify 4 over 10. So we are going to factor 4 as 2 times 2 and 10 as 2 times 5. Next, cancel out the common factors. And the answer is 2 over 5. Let's now have the steps in simplifying rational algebraic expressions. The first step is factor both the numerator and denominator. Therefore, in simplifying rational algebraic expressions, you must have mastered the factoring. And number 2, cancel out any common factors. Let us have some examples. Example number 1. Simplify 4a plus 8b over 12. So the first step is to factor both the numerator and denominator. Let us factor the numerator 4a plus 8b using common monomial factors. And the greatest common factor of 4a and 8b is 4. 4a divided by 4 is a. 8b divided by 4 is 2b. And let us factor 12 as 4 times 3. Next, cancel out any common factors. So the answer will be a plus 2b over 3. Let's have example number 2. Simplify 3x minus 12y over 4x minus 16y. So again, we're going to factor both numerator and denominator using common monomial factor. The greatest common factor of 3x and 12y is 3. 3x divided by 3 is x. Negative 12y divided by 3 is negative 4y. The greatest common factor of 4x and 16y is 4. 4x divided by 4 is x. Negative 16y divided by 4 is negative 4y. Cancel out the common factors. So the answer is 3 over 4. Example number 3. Simplify 15c cubed d raised to 4e over 12c squared d raised to 5w. So let us factor 15 as 3 times 5. C cubed is c times c times c. D raised to 4 is d times d times d times d. And copy e. Next, let us factor 12 as 3 times 2 times 2. C squared as c times c. D raised to 5 is d times d times d times d times d. And copy w. So cancel out the common factors. We have now 5 CE, and then 2 times 2 is 4 dw. So the answer is 5 CE over 4 dw. Example number 4. Simplify x squared plus 3x plus 2 over x squared minus 1. So let us factor the numerator using general trinomials, and the factored form will be the quantity of x plus 1 times the quantity of x plus 2 over, let us factor x squared minus 1 using difference of two squares, and the factor is the quantity of x plus 1 times the quantity of x minus 1. Let us cancel out the common factors, and the answer will be x plus 2 over x minus 1. Example number 5. Simplify y squared plus 5y plus 4 over y squared minus 3y minus 4. So let us factor both numerator and denominator using perfect square trinomials. And the factored form will be the quantity of y plus 4 times the quantity of y plus 1 over the quantity of y minus 4 times the quantity of y plus 1. And let us cancel out the common factors. The answer is y plus 4 over y minus 4. So that's all for now. Thank you for watching.